This week we're on lesson 15, mixed numbers and improper fractions. So go ahead and take a minute to write down this vocab. So a mixed number is where we'll start. That is just a combination of a whole number, so like 5 plus a fraction. So 5 2/3. It means you've got 5 pizzas plus another 2/3 of a pizza. A proper fraction, something like 4/7, where the top number is smaller than the bottom number. Improper fraction would be something like 9/4, where the top number is bigger than the smaller or than the bottom number. So we're going to be working on converting between these two fractions, mixed numbers and improper. So one way we can do this is by looking at a visual. 2 1/4, well, that means we basically have a whole plus another whole plus a fourth. If we break these up into 4s, so that's what we have right now. What we're going to do is split the wholes up into fourths as well. So you split them up into whatever the fraction is. So here it's fourths. 2 means we've got 1. It would be easier if I used a different color. Like that. So now you just count how many parts do we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 2 1/4 is the same as 9/4. Same thing, if you feel you got it, go ahead and pause it and try it yourself. 1 3/5. So we've got a whole plus the fraction. The fraction is split up into fifths. And we see it's 3/5, so it'd be 1, 2, 3. We'll split the whole up also into fifths. So again, whatever this is, that's what you split all the different parts up into. This one is for the whole, it's like that. And then you count, you've got 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 8/5. Going the other direction now, going from improper to a mixed number. What we're going to do here is figure out how many wholes are there in 9/4. So we'll split these up. So basically think how many times does 4 go into 9 until it gets too big. You go 4, 8, 12. So that's 3 times. So that means we need 3 boxes. We're going to split these up into fourths. And then we just fill in how many we have. We've got 9 of them. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Looking at that, this is a whole, and then 1/4. So 1 plus 1 plus a fourth gets you 2 1/4. So 5 goes into 12 2 times, and 3 would be extra. So we'll do 3 boxes. 1, 2, 3. Split them up into fifths. And just fill in how many you have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's a whole, and then 2 out of 5. Add those together. We get 2 2/5. Now, at this point, there are other ways, and your parents have learned other ways. By all means, if that's the way they go with, they want to show you, go with it. But this is just so you have a visual understanding of how these conversions work. 3 goes into 5 1 time with 1 left over. So that means we're going to do 2 boxes, split it up into thirds. So 1, 2, 3, 4, 5. So that would be 1 2/5. Exponents are going to start showing up. All an exponent is a way to show repeated multiplication. So you'll see the two examples here. This we would say as 3 squared, or 3 to the second power. 3 squared means you take 3, multiply itself by 2 times, so 3 times 3 equals 9. This one here would be 2 to the 4th power. Two to the 4th power means we multiply the base, which is 2, times itself 4 times. So 1, 2, 3, 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. If you have a cubed, so a 3, so it would be 4 to the 3rd power, we would say that 4 cubed. That would be 4 times 4 times 4. It could be 64. So then we can use exponents to find areas of a square. So remember a square, the definition, 4 sides. Those sides are parallel. They are also what we call congruent, which means all 4 sides are equal. So if we know that one side is 5 feet, that means all the sides have to be 5 feet. So to figure out the area of a square, we can do area equals s squared. So area here equals 5 squared. When I plug a number into a formula, I like to use parentheses to know what I plugged in. 5 squared equals 25 feet squared. On formative, start doing it like this. The square feet, or like writing it out, usually isn't in the key. So you can just do feet to the second power. Couple of review. So 2/5 of the students are boys. 4/9 of the boys play basketball. How many boys play basketball? These are questions that looks like we're still struggling with. One way we can think about it is, let's look at an area diagram. So 2/5, that's 1, 2, 3, 4. 2/5 would be this much, right? And then we're saying 4/9 of that, so then we can go the other direction. 1, 2, 3, 4. Can't remember. But that's ninths, and then 4/9 of those, so that would be 1/9, 2/9, 3/9, 4/9. What we want is the overlap. We want this overlap here. Because really, the 4/9 goes all the way down here, right? So where those overlap, we count. That would be 1, 2, 3, 4, 5, 6, 7, 8. But we know this is a fraction, and a fraction is going to be less than 1 because you can't have more than a whole when you're talking about students or who plays basketball. There's 100 students. You can't say 115 of them play basketball because there's not 115 students. So our fraction would then just be how many parts in total in this entire thing. So 1, 2, counting those, we're running out of colors, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, on over ends up being 45. So 8/45 play basketball. The other way you can do that, if you look at the numbers here, so 2/5 and 4/9, how would you get from 2/5 and 4/9 to 8/45? Well, you would just multiply straight across. Billy ate 2/3 of a pizza. So 1, 2. Neil ate 1/8. 8, it's a little harder. How much did they eat in total? So you would just do 2/3 plus 1/8 here. That would be 16/24 plus 3/24 equals 19/24.